Hello and thank you everyone for attending today's webinar, The Servo Worm Gearbox, Debunking the Myths of Inefficiency and Inaccuracy, brought to you by Design World Magazine and DieQua. We would like to thank our presenter, Tom Kahn, for being here today. I'm Mike Santora, Associate Editor for Design World Magazine, and I'll be your moderator. Just a couple of housekeeping details before we get started. You will see several boxes on your desktop, all of which can be moved around to suit your preferences. Initially, the Q&A box is at the lower left. This is where you will enter your questions for the Q&A session. Another box to note is the additional resources, initially at the lower right-hand corner of your desktop. These resources are for your information needs. We also have a tweet box right on the desktop, so feel free to tweet any interesting points right from there, and there's a list of hashtags for you to use as well. Tom Kahn is the Motion Products Manager for DieQua Corporation. Kahn's product management experience includes working with internal and external sales groups, as well as channel partners, to develop strategies and programs for new product rollout and sales activities with customers, distributors, and system integrators. And so, without further ado, here's Tom Kahn.
Mike, thank you. Good afternoon, everyone, and thank you for attending our webinar this afternoon, talking about our Dynabox Servo Worm Reducer product. More specifically, to actually take a look at some of the myths and misperceptions that travel with the worm reducer product. And some of those include things like inefficiency. They're not suited for servo-based motion. Some might say that their backlash isn't as good as other reducer solutions. And lastly, that they may have an issue with servo capability with regard to acceleration or deceleration. And we'll be touching base on that for the next 30 or 40 minutes to go through where this product really excels in application, performance, and capability. So when we take a look at the Dynabox product, why choose a worm-based solution? Well, uniquely, you have ratios from 5:1 through 90:1 in a single stage, and in a very compact housing design, sizes ranging from a size 25 through size 110. And what that references is the center line of the input to the center line of the output, so that you have gearboxes that span in size from roughly a 1-inch to about a 4-inch separation, giving you a pretty broad range of both reductions and torque capacities. We talked a little bit, or mentioned, what is unique about the worm gearbox with respect to it being a space-saving solution. And here we can see in the background a traditional planetary, either single, double, or triple stage, along with its motor, can produce a fairly long axial stack length. This could become an important consideration or issue if the machine occupies a very tight footprint within the production environment. So is true with a bevel planetary. Now we start into a right angle solution. And you can see that even with the planetary construction, we still intrude into the floor plan of the plant environment. In the foreground, we have our Dynabox right angle worm. In its compact design, we intrude into the floor space in the smallest design, almost 4 inches, and out to about 2 1/4 inches. So this permits a very compact, neat, clean system integration of motor reducer into the machine, and the ability to tuck it right into the side of the machine frame. We now take a look at some of the output configurations The first, most traditional, is a hollow bore with key, and that provides interface of a 20 through 60 millimeter keyed motor shaft. The hollow bore with shrink disc is probably the most common and the most popular. It ensures a firm connection, non-slip interface to the customer's motor shaft by compressing our shaft directly onto the customer's input connection. And that also spans from a 20 to 60 millimeter shaft input. The also traditional connection is either a single or a dual output shaft, as might be used in applications where you need to have both a right and left mechanical interface out through the reducer. And that can accommodate shafting from 25 through 75 millimeters. The last and gaining popularity for mechanical connection to a machine is the robot flange, which conforms to the ISO 9409-1 standard. This permits robotic-grade accessories direct interface to the output of the reducer. It also provides, and we'll talk about this a little more later in the presentation, a large hollow bore through hole should you need to pass plumbing, electrical, or other connections up through the center of the reducer. Moving through the next portion of this presentation, we're going to talk about what is it that makes this product stand apart from the more traditional industrial worm product. And you can see by the cutaway that the construction is unique to other worm products, industrial worm products in the market, both in the worm and ring gear design and how we support and manage control of the worm shaft. Additionally, the zero backlash connection from the servo motor as an input directly to the Dynabox product. So here we're looking at an animation and an actual photograph of the worm shaft. In particular, what makes the Dynabox worm shaft unique is that it has a dual compound grind. As you move from the left of the worm to the right, you can see that the worm flanks go from a thicker to thinner profile. This delivers to the customer the ability by part number to actually have a less than 1, 5, or 10 arc minute backlash. This is unique into the industry. Even looking at a planetary configuration with a backlash level of less than 1 in a single stage is unique. The way that we accommodate or accomplish the backlash adjustment, this is done during assembly of the reducer. On the left side of the gearbox housing, you see the components that are used to maintain and control alignment of the worm shaft. So that this is a preload construction. It uses taper roller bearings to maintain and control alignment of the worm shaft, and managing thermal expansion of it is critical. Recognizing that during assembly, it's critical that when we shim the preload, this sets and maintains that backlash adjustment. Here we're looking at the support bearing structure that I mentioned in the previous slide, and you can see the dual taper roller bearings that are used in the preload to maintain alignment of the worm. We know that from a worm gear's operation being a sliding friction, that during operation, the worm shaft will expand as it heats up. We manage the alignment by a third bearing structure that floats within a thermal expansion to maintain very precise control of the worm and ring engagement. This axial free float bearing structure that you see toward the center of the top image permits the worm shaft to elongate, never binding or changing. So backlash is consistent through the performance of the reducer as well as during its longevity, which is upwards of 20,000 operational hours. As I just mentioned, we know that the worm shaft will elongate and that thermal expansion has to be managed. And that's done with a torsionally rigid stainless steel zero backlash coupling. This is the mechanical connection between the worm shaft and the output of the servo motor. This coupling isolates any movement of the worm and its elongation or any changes of dimension that the servo motor might also contribute. Additionally, from this connection point, accommodating the broadest possible range of servo motors, many flange options are available to mate virtually any servo motor on the market. When we look at the connection of, as we previously mentioned, of hollow bore with key, shrink disc, single or dual shaft, or robot flange, it's critical to also have complete flexibility in interfacing the housing to the customer's application. So whether we're directly shaft mounting the reducer or it's mounted onto the customer's application, the machine, the greatest flexibility is presented with a variety of through holes and blind tapped holes. Additionally, in order to minimize weight and increase thermal transfer out to the air from the reducer, we use a aluminum magnesium alloy, higher strength, lower weight, and superior thermal transfer. We also, when you look at the machine surfaces, these are done to engineered tolerance, and that ensures repeatability and consistency for proper alignment both to the application and mating of the respective servo motor. I mentioned earlier that the Dynabox has a 20,000-hour operational life. This is accomplished, as you can see in that bluing depiction of the ring gear, during construction and production of the units, the technicians will apply a lubricant that has a blue pigment into the grease. This permits us to actually see the contact pattern and the area that is utilized. In the case of the Dynabox product, we utilize more than 90% of the gear face. This ensures longevity, performance, and consistency of operation. When we analyzed competitive units, you can see that a significantly smaller portion of worm gear engagement occurs. Typically in a worm construction, the worm shaft is comprised of steel. The ring gear is a bronze or a bronze alloy. In the case of the Dynabox, it is a proprietary bronze alloy. It delivers longevity and the nature of the worm tolerating a higher shock load. Also in mentioning, in the case of a worm gear set, the gear train actually utilizes a wiping action. This also permits or delivers to the applications a significantly quieter operation. Typically sound levels as low as 50 to 55 decibels are realized because of this wiping action. That wiping action is also where that heat accumulation comes from, and managing that is something that the Dynabox was thoroughly designed to facilitate. Mentioning the utilization of the worm to ring interface, also critical is the finish during production of those geared components. And here you see a sample of the two competitors as compared to the Dynabox. Clearly, the attention paid to the production of that gear set is critical to longevity and performance, specifically looking at life and backlash capacity. Transmitting the torque, the connection between the output flange and the ring gear, we utilize a pinning process as well as a permanent Loctite gear compound to ensure that connection is well maintained and is consistent. I mentioned that the casting process of the ring gear is a proprietary bronze alloy that delivers superior performance, lubricity, and delivers a consistent and predictable long life. When we connect the output shaft components together, this again is a permanent connection. Here we see an image of the ring gear, the locking nut that is a permanent bond to the output, and then the oversized taper roller bearings that deliver very high axial and radial support capacity. An example, our radial capacity peaks out at about 21,500 newtons and axial support at about 16,000 newtons. This is true for the entire range of the Dynabox product. I mentioned earlier one of the more unique connection capabilities of the Dynabox reducer is that robot flange. And here you're seeing imagery of side view of the robot flange, the large hollow bore connection, and those bores range from a 25 millimeter up through 80 millimeter. This again ensures or provides the ability to pass power, plumbing, pneumatics, optical through the hollow bore, the center bore of the reducer. Connection to the customer's load is done with a combination of drilled and tapped blind holes as well as a dowel locator pin. This ensures very positive connection without concern about slippage between the load and the reducer. We look at the areas of application that this product excels in. Typically are applications that demand a very compact design, efficiencies that approach 95%, but are also very quiet. In the case of laboratory, office automation, theatrical or entertainment, noise is an issue. In applications that require very, very low backlash, printing, robotics, positioning in special machinery, this product, again, has a capability of down to less than 1 arc minute, unique for a single-stage product. When we look at certain applications that also demand the unique capability of providing the option of being non-back driven. In other words, in a vertical application where you might have a belt-driven actuator, it is advantageous to have the ability not to be back-driven. Typically, ratios greater than 30:1 have the capability of being self-locking. Ratios above 50:1 are non-back drivable. So if you're looking to perform a vertical application, here we have the ability to hold the load in position without requiring a brake to be used all the time. In these applications, whether it was press control for performing cutting or edge alignment, repeatability and getting to position without having backlash become a consideration, our Dynabox lent itself well. In the communications application, torsional rigidity and backlash control was also a major consideration. Also the non-back drivability. The dish needs to be held and locked into position. That product lends itself well. In machine center tooling, space becomes a premium. A right angle solution puts the motor and reducer into a very confined package. And the same is true with customer special automation applications. Space is always a premium. And having that 4-inch side-to-side dimension lends itself to tucking the reducer into a very tight space. The unique application for a moving stage, theatrical. We had to ensure that there was no sound present during the moving of the performance, and because of that, less than 55 dB, the Dynabox delivered that capability. A quick summary of both series. The DB series is a size 25 through 110. That's the aluminum housed unit and has the 5 different output capacities with very low acoustic signature. We offer 3 larger sizes that happen to be in a cast iron construction that also has torque capacity up to 8,000 Newton meters. A little tighter backlash. The expert iteration is 0.5 arc minutes of backlash, but this is limited to either hollow bore with shrink disc or hollow bore with key. So that, in summary, when we look at the Dynabox product, there is a perception that across the board, the units are inefficient. Now, in applications that typically have frequent stop-starts or very low and slow speed, efficiency is a consideration. And when you look at the functional capacity of the gearbox with ratios from 5:1 through 90:1, we typically are looking for middle speed ranges. We can handle from 1,000 to 6,000 RPM of acceleration, and our efficiencies approach 90 to 95% in the mid-band range of torque and speed. This brings to the table a consideration both from performance, cost, and space savings that is unique to the Dynabox series, both the Compact DB and the larger XL series. I appreciate everyone's time this afternoon and welcome your questions and thoughts. Contact information, if you'd like to reach us or myself, please feel free.
Thanks, Tom. So, yeah, we're going to open it up for questions now. Tom, the first I have coming in is, what levels of efficiency can your DB series worm box deliver?
So when we look at the performance of the unit, we're typically looking at servo motors that have, let's say 3,000 RPM is a rough average. So if I take that as a starting point and I'm looking at a motion profile that has stops and starts, and I take a mid-level unit, in a 10-to-1 reducer, I'm at 92% efficient. And that holds pretty true through all 10 sizes of the DB series. As you get up to higher ratio, higher speed, that will fall into the probably 62 to 65% range. Great question, by the way.
Mm-hmm. So the next we have is, what backlash can I get from your Servo Worm reducer?
So the very basic version out of the box has a less than 10 arc minute of backlash. We also offer two smaller backlashes available, a less than 5 in the medium, and in the basic, a less than 1 arc minute of backlash. And that's guaranteed through the 20,000 hour operational life of the reducer.
That actually brings us to the next question. Now, what is the life expectancy for the worm reducer?
Typically, we're looking at 20,000 hours of running life for the reducer. True to any geared product, there is a period of break-in that you'll want to run the reducer through to eliminate any high spots on any of the gear train. Operationally, we're looking at 20,000 hours.
Okay. And Tom, how does your reducer maintain those levels of backlash?
During, well, first speaking to the utilization of 90+% of worm ring to worm shaft engagement ensures more wearing surface, also higher shock load because we're distributing the use over a broader area. Speaking to the expert version, during construction of the unit, the technicians assemble and then confirm that we have met the backlash expectation, in the case of the expert, less than 1 arc minute.
Okay, I want to keep moving through here. Tom, the next question we have is, when it is applied for a vertical lifting situation, what is the holding torque identified and impact capacity?
When we look at the torque capacity of the gearbox, in particular, we reference 3 different classifications, and it is a function of lead angle of the worm shaft relative to the pitch. So the finer the ratio, in other words, when we get to 30 to about 50 to 1, the lead angle becomes steep enough that the reversibility class, we break it down into a class 1, 2, or 3. When we look at from a 5 to 1 to, say, 25 to 1, there is a high probability that the load will overhaul or backdrive the reducer. As we get into the 30 to 40 to 1 ratio, that has a class 2, and then above 35 north to 50 up to 90, it's considered non-reversible. Now, I do stress the point that in cases of vibration, it wins out overall. So we are non-backdrivable with sufficient vibration. The actual torque number is varied by how much the actual load is and the orientation of the load itself. That would be an application-by-application basis, and we'd welcome handling the question directly.
Okay, so this next one, somebody just asked about what's the most common misconception or myth you've heard about servo worm gearboxes?
Inefficiency is probably the single largest one, and that they don't tolerate high-speed input well. That is certainly true in industrial worm reducers where, and we speak from experience because we do have a couple of lines of industrial worm gearboxes, that those are typically designed for power transmission applications. They're brought up to speed and they maintain their speed regulation very well. What happens when you have a higher ratio and you subject the worm to rapid acceleration, it will function like a screw, and without that preload, you run the risk of actually having the worm shaft ejecting out the back of the reducer. Because we utilize a rigid preload and that engagement point is controlled by those shims, we ensure that we accommodate up to 6,000 RPM acceleration.
Okay, I'm going to keep powering through here, Tom. We have a lot of great questions, and I want to get to them. So next we have, how does backdrivability vary over the life of the gearhead?
The grind profile to the reducer is identical on both sides of the worm shaft and the ring gear. So we do not have dissimilar torque numbers, whether it's clockwise or counterclockwise. And when maintaining that expert iteration with a less than 1 arc minute, as so long as the load is not exceeding the capacity of the gearbox, it's still considered a function of operational hour.
And Tom, what are options for encoders on the reducer output shaft?
That's an interesting question. Typically, people will use encoders on the motors. We have had other applications where we will customize the reducer and use a blind hollow bore, depending on the application, whether it's an interior or exterior application. The customer was not fully rotating the output shaft, but needed the capability of very precisely measuring angular deflection. And we used a reduced OD on the output shaft to accommodate the 12 millimeter input on the blind hollow bore encoder. We incorporate an anti-rotation pin to hold the housing in position. We can also put a safety cover over the encoder so that it doesn't get inadvertently used as a footstool. But certainly on, if it's a shafted output, we can extend the shaft out the backside to accommodate that, adding that encoder.
Okay, Tom, I'm going to take 2 more questions, and then just to be respectful of everybody's time, we will wrap things up. So first of the last 2, can I get DieQua to customize the gearheads to certain requirements?
Absolutely, and that also is a really good question. The Dynabox has the ability to have modifications both to its output, because it's an aluminum magnesium housing, we have had food grade applications where it became essential to provide an FDA white epoxy to the unit. From a mechanical standpoint, altering the mounting configuration was something we did. We also needed the ability to provide dual servo motor operation, and this was facilitated by dual worm shaft input, and it permitted in 2 applications smaller motors but delivering larger torque numbers out the gearbox. But in another application, the capability in an automotive application of a hot swap should one servo motor amplifier develop issues, the backup unit was automatically brought online to continue the system's operation.
Okay. So Tom, for the last question before we wrap up here, someone asked, where do these worm gearboxes compete against other gear options? Or where would you not recommend one of these worm gearboxes but maybe something else from DieQua instead? I mentioned efficiencies in lower speed type applications or applications that have frequent stops and starts. In lower speed applications where we're causing the motor to start and stop, because it's sliding friction that we're overcoming, we need to take into consideration the no-load starting torque and the capacity of the motor. So whether it's a gearing technology from DieQua that would be a planetary solution, a helical bevel, spiral bevel type gearing, we'll look at what the ratio is, the amount of torque, the degree of customization, and we'll work very closely with the customer in consulting with the best solution for the application. Okay, well, thank you again, Tom. A lot of great information. Still had a few questions in there, so I just want to remind everybody that if you had any additional questions we did not get to today, you can refer to the speaker bio box containing contact information for Tom or myself. And of course, I want to thank everyone for attending this webinar from Design World. This presentation will be emailed to everyone later today and will also be available at www.designworldonline.com.